In this example, we will take the equation theta equals pi over 4 from an equation in polar coordinates into an equation in rectangular coordinates. Now, since we have an equation in polar, if we do want to try to convert that into rectangular, we do have a few formulas available to us, such as r cosine of theta is equal to x, r sine of theta is equal to y, r squared is equal to x squared plus y squared, as well as tangent of theta is equal to y over x. Our goal will be to take this equation and try to do something to both sides so that maybe we can get it to look kind of like one of the equations on the right. Well, we do see theta represented in a few of these equations, such as r cosine of theta equals x. If we try to take cosine of both sides of this equation and have cosine of theta is equal to cosine of pi over 4, well, that seems to go fine on the right track of things to get cosine of theta is equal to the square root of 2 over 2. However, I still don't see r cosine of theta, which means I would want to then try to multiply this by r to get r cosine of theta equals r times the square root of 2 over 2. And now I've done a couple steps that allows me to replace the left side there with now x, but I now have introduced an issue on the right side with an r that I don't know how to replace. So maybe applying cosine was not the best strategy. And that would also apply if I tried to use the second formula listed on the right side there, with r sine of theta equals y. If I take sine of theta both sides and then multiply by r, I'd still run into the same issue. So then let's look at the last equation involving theta. Tangent of theta is equal to y over x. Well, that just means I just need to take tangent of both sides, and then I can replace tangent of theta with y over x. That's a little bit simpler. There's less that needs to be done, and no complications that will arise, as I'm not going to need to multiply and work with r at all. Here then we would have tangent of theta is equal to tangent of pi fourths is just 1. And then I can replace tangent of theta now with y over x equals 1. Or, to get y by itself, even though the question doesn't ask that, we can do so. This is just y equals x, aka a straight line.